Welcome back. In today's video, I'd like to take a quick look at an important idea that relates to inheritance in Java. To wrap our heads around what we're going to talk about, I think it's best for us to start in an existing project and system. So let's take a look at the code we have in front of us. Here's the main method of our program, and what it does is it creates a list of objects. These objects are either of type book or poem, but we've placed them into a list of literature objects, leading us to believe that the book and poem classes must inherit from or extend the literature class. Then once we've built that array, we simply iterate through it using a for loop and call this print method on each object. At this point in time, we're dealing with the objects as literature objects, not the books or poems that they are at the lowest level. This leads us to believe that the literature class itself must implement a print method. And if we jump into the class, we'll see that indeed that is true. However, if we run our program, we quickly see that books and poems execute their print method slightly differently, displaying different information for each of them. This is explained when we look in the book and poem classes, which do indeed extend literature. But each of these classes override literature's print method to provide their own functionality. This is all well and good and is a pretty elegant solution here. But there's an interesting case that we should take a look at and discuss. Because literature is itself a class, it's perfectly valid for us to declare a new literature object, just as we could a book or a poem. If I remember correctly, literature's constructor expects first a title for the piece of literature, and then an author. And once we've created a new instance of the literature class, we could put that instance into our list of literatures, just like we've been doing with instances of the book and poem class. When we do that and run our program, we'll see literature's print method executed, and the new literature object we created will display alongside our list of books and poems. So what's the problem here? Well, depending on the true nature of the software we're trying to design, this may or may not make a lot of sense. Let's say we're doing this as part of a library system, providing someone with just this information, that something called Java was written by some guy called Zach, without telling them if it's a book or a poem or any other information that we've decided to associate with specific types of literature, may simply be not useful at all and something that should just never be done. If this is the case, Java provides us a system to create classes that we can use for inheritance purposes, but will never be able to be legally instantiated on their own, as we've done here. If we want to mark a class to be of that type, we're going to call it an abstract class. And in the class's declaration, we simply use the abstract keyword. Once we've marked a class as abstract, it's no longer a legal operation to instantiate this class. On its face value, this is a really simple thing, and primarily a protect our code from ourselves and other programmers kind of deal. But that's not entirely true. Or rather, it is true, but it's not the only purpose of declaring a class to be abstract. Once we've told Java that we can never create an instance of just a literature, only of classes which use literature as their superclass, we're no longer as restricted when setting up the literature class. Because we've declared literature to be an abstract class, we, and Java as well, know that literature will never be instantiated on its own, only when it is a superclass of a class being instantiated. When this is the case, we can get away with not having portions of this class that most Java classes have to have. For example, we don't need to actually declare a constructor for literature. If literature was a standard Java class, Java would not be okay with this, because if we did try to instantiate literature, it would have no idea what to do. There would be no constructor to call. But because literature is abstract, we can be confident that literature's subclasses will have constructors of their own. Of course, if we do make this change, we're going to have to get rid of the references to the literature constructor in our subclasses. So there's definitely a trade-off associated with this change. It requires more code in our subclasses to have less code in our literature superclass. In this particular instance, this trade-off probably isn't worth it because we're duplicating code between our book and poem constructors. But if the constructors for literature subclasses could be reasonably assumed to do very, very different things, not declaring a common base constructor would make a lot of sense. So, in summary, when we architect our program or a larger solution so that we have classes that make a lot of sense for architecture purposes, but should never be created all on their own, we want to declare those classes abstract. Sometimes we'll really know we've come across a class like this when certain common class functionalities, like having a constructor, just don't make sense for this class. As always, thanks for watching.